Hi everyone, this is Chad, and today I'm going to be taking you through a tutorial on how to construct plan oblique drawings of a small pavilion. The pavilion that we're going through is the Newspaper Cafe by Toshiko Mori, and it was built in 2007. These are just some images of it. It's sort of an interesting little thing that's going on, thin and narrow, and has a ramp that wraps all the way around it. You can see this little child moving up the ramp, and I guess it holds newspapers. I don't know too much about it. This is Toshiko Mori, and an assemblage of photos of her holding models and grinning into the distance, which is just like a classic architect portrait thing to do, like narrating her models, etc. So it's sort of a neat project, and we're gonna take some orthographic drawings of this and use those drawings to construct our drawings of it, which is a pretty similar process that you guys will be going through in your project, I believe. So the first thing to do is, you'll have all the orthographic drawings provided, I believe. Anita and Victor have been hard at work on that, but I have my own. So to start, what we're going to do is we're going to type in picture to import these pictures, and we'll select the orthographic drawing that you desire and just sort of arbitrarily scale it in there, and then we'll finish that we'll repeat that process with this drawing. And they're at a different scale, so they don't need to be the same size. And I have included on my drawings this little graphic scale, and I believe that your drawings will have one of these as well. Just it'll likely look different from this one. And what a graphic scale does is it allows you to know that regardless of the size that this image is, this line right here is 2.5 feet, or between these 2 points is 5 feet. So I can scale that up, or as long as it is shift constrained, I can scale that up and that remains true, and I can scale that down and it remains true. So graphic scales are a great device if you want to know a scale without, but you're just arbitrarily printing a sheet, or are arbitrarily printing drawings that other architects have done without knowing the scale that they were drawn at. And generally you can reference such things like known dimensions as doors, etc., to help you determine what those units are. So once you've arbitrarily placed these drawings in, what you're then going to do is we're going to select that drawing. Actually, I'm going to place these drawings in a separate layer. Which may be helpful in the future, but we're going to select those drawings, and we're going to type in scale, and then we'll click as close as we can to what that point is. And it's not going to be perfect because these are rasterized drawings that we're processing in a vector program, and then you hold shift because your graphic scale should be constrained orthographically, and then you'll click on that other point as close as you can. And now that you're sort of scaling, you'll just not click again, and you'll type 2.5 feet, or whatever the known dimension is. In my case, it's 2.5 feet. And then you'll press enter. And now, if we go to the distance command and find the distance between those points, I clicked in different locations, but it's roughly 2.5 feet. You can see up here in the top left corner, it says 2.49 feet. And then we'll repeat that process over here. relatively try and get it perfect, and 2.5 feet. And now, what we're going to do is, I think it helps. Let me rename this. That drives me crazy, not having all the cases the same. And then I'm going to make a new line, or new layer that is construction lines. C lines. Gotta get creative sometimes. And change the color of that. And what I'm going to do is, it helps, I think, to roughly articulate or roughly place all of your different drawings relative to one another. So if we know that this ramp starts here, well, let's actually refer back to our drawings, I think, or our photographs. The top of the ramp is on this, like, the outward side of the angle. I don't know exactly how to refer to that. The leeward side of the angle. And the newspaper structure is on the opposite side of the upper portion of the ramp. So let's now go back to this. And we know that, so this is the structure that that newspaper sort of goes into. And this right here is the bottom of the ramp. This is the top of the ramp. So this elevation corresponds to this side. And it's inverted for the purposes of us correlating the drawings to one another. But we know, just taking some construction lines up at different points, sort of relative points like corners, etc. That corner of the pavilion, and then that piece of the ramp. Oh, I guess this is just the inset. So this is actually the corner of the pavilion. And now we should be able to move this in such a place that all those things are sort of working for us. It sort of seems like where it'd be, but it may be improperly scaled slightly because there should not be this overhang here. But that's part of this. So now I guess we'll, even though my graphic skills were incorrect, I guess now we will scale that drawing relative to this. And I think probably you guys will begin with a single drawing that has a graphic scale to it, and then you'll scale all of your other drawings relative to that one. And I think we could sort of move that one over a little bit. And yeah. So now that we have two drawings placed in sympathy to one another, and you guys will have like sort of a whole set of drawings that you're, correlating with one another. Actually, here's an example over here. We've already done this, so Erica so gracefully set up this whole file and correlated all the drawings to one another. So you can sort of see how this may play out. And I guess perhaps that's what was going wrong with this over here. It's the relative rotation. But I think, yeah. So if we rotate this differently, if we were to rotate this differently, perhaps it likely ends up like, so if you need to rotate drawings, here's what I always do. I draw an orthographic line, and then I draw my the line that corresponds with the place I'm trying to rotate to orthographic. And then I select those, I type in rotate, like so. And perhaps this will, let's rescale this image because I messed around with the scale of it. Now perhaps if I move this around, and I'll draw a new set of construction lines here. Up from those same prominent corners. And yeah, aside from a little nudge, it looks like that's about it. That's about what we've got. And that, and the bottom of the ramp here corresponds with the bottom of the ramp point here. So I think that that makes sense. And that's the south elevation. Okay, so now that you have your drawings correlated, and it can be sort of a circular process, kind of like how I've just demonstrated. It doesn't necessarily follow in a linear progression. But once you have that, some of your drawings correlated, what you're going to do is you're going to begin a process of mindful tracing. And actually, I'm going to switch over to this larger, the full armature that you guys will create prior to tracing. We'll begin sort of that process of mindfully tracing these things. And what mindful tracing means is you're thinking about, like, it's a little bit more precise, I guess, than it's a little bit more precise than the tracing you guys used on your previous project, because it's correlating to a dimensioned object. So you want to make sure that parallel lines are parallel. You want to make sure that which you guys were doing to some degree in the last example. And sometimes you want to make sure that things happen to no units as much as can be controlled. And what you're trying to do is you're trying to recreate a vectorized drawing of the pavilion in question. And actually you can see now this has an even more precise rotation of the elevation than mine, so it doesn't actually correlate to any, no side is in orthographic. The elevation doesn't correspond to any one side, which is why there's a slight discrepancy between my scaled elevation and my scaled plan. Anyway, so you'll begin the process of tracing these drawings, and so we'll, as best as we can, draw these things, find the known points. About there works for me, and then I'm a big fan of the offset command in order to get parallel lines. And if you offset and then you press its through point, or T, and then enter, you can sort of relatively offset based on the position of your cursor. So you can position your cursor over that other line. And we can generally assume that this wall, especially considering that it looks to be the same thickness, we can assume that it is the same thickness. So offset's a pretty appropriate command. We'll trim away that little tag that occurs. And then cap that wall. We can also, well, can't necessarily assume that those caps are perpendicular to your wall lines. Sometimes that is the case, sometimes not. It looks like in this pavilion it's not the case on this right side. And we will just continue to trace this. In fact, I don't think it's the case on this side either. So we'll just trim away any lines that we're unhappy with. And yeah, just continuing that. Not everything's going to be parallel, but some things will be. I think it'd be helpful to trace our ramp. That'll be one of the prominent things that we're drawing. And tracing, especially in the context of an oblique drawing, can be a little bit of a back and forth. Like, you'll think that your trace is sufficient, and then you'll realize there's an element that you need to construct that you don't have the plan for. So you'll just go back to this drawing, and it's sort of a constant back and forth between your respective drawings to construct it. And then do that. And this drawing's complicated by the fact that it happens at sort of many angles. So there's less to correspond with. But yeah, this is just how this process goes. Perhaps that. And do the through point. Yeah, that looks like that'll be parallel. As much as possible, I think it's good to keep parallel lines parallel, etc. That's not necessary. That's not right. It insets from the structure, and that looks about right. So yeah, so that's how tracing will proceed. The important thing about tracing is that you have is that you get the elements that you need to get, and just like the basic outline, I think for now is sufficient. I'm gonna switch modes actually. and utilize the one that Eric has already constructed that we've used to construct our plan oblique. And actually I'm going to add one little detail item that will help, that I already can recognize will help us in the future, and that is these little structural elements that occur so prominently across the facade. I know I'll need those, and we'll need to send those up. So using the rectangle command and the 3-point, that's I think thick. And about there. And then because structural elements are always the same, or not always the same, but they appear to be the same in this case, we will duplicate those and then copy that spacing that we've made across. And that seems to be about correct. We're a little bit off. Again, and copy across. That looks great. And then these members will rotate relative to this face, but for now I think it's sufficient that we do it this way. So the next step in constructing our oblique, and this is when it, I guess, gets a little spicy or interesting, is we'll take our traced plan and we'll copy and paste it, and then we'll move it off to the side. But I would recommend that we move it over by like some known dimension, because this is a true scaled like set of drawings. It'll be a little bit large, so maybe like if we move it over 250 feet, that's sort of an appropriate distance, I think. And the reason we want to do that is that we know now the distance between our respective drawings, so we can move things back and forth if we need to. Although the next step of drawing a plan oblique drawing is that we'll rotate our plan by some angle. Erica and I have elected to rotate it by 45 degrees for the purpose of this tutorial, but you can also rotate it 15 degrees, 30 degrees, or 90 degrees in certain cases, and still make a plan oblique. So what I've done here is I'm just adding a reference line, a datum, from which I'll rotate this plan. That way I know how to get my plan back to its original orientation, or I'll know how to rotate things, a point to rotate them from, if I need to like bring things from my traced plan back over to my plan oblique. So now I'll type the rotate command and rotate over, and then type in 45 degrees. And now I have a 45 degree drawing. From here, the process of a plan oblique, and just sort of, this is pretty diagrammatic, but the basic process is just to project lines from the plan up at the respective heights that they occur on your elevation. So you could almost imagine if this was simply a square, or, you know, an odd profile shape and it was 10 feet tall, we could copy this up by 10 feet. And then trim away some of these lines. And this right here would be, once we trim away the interior, would be roughly our plan oblique drawing. But because this pavilion has varying heights, that's not exactly how it works. But the theory or the idea behind the moves and steps we're going to take is all the same as that. What we're going to do is we're going to find known reference points and use construction lines to draw lines up from those points and correlate them with our elevations. Either our top elevation, the elevation we have below, the north elevation, or our east elevation over here. And between those points, so we'll, for example, if we want to find the point, the height of this outmost point of the ramp, we would send a construction line down to the elevation that ramp occurs on, to the proper elevation, and we can see that the intersection point between the ramp and that line we drew down is 0 height. With that said, if we want to find this point on the ramp, this outer point on the ramp, we would take that intersection, project down, and then at this intersection, we would find the height from ground. And it also is helpful to draw a ground line on each of your elevations so that you have a consistent point of reference from which you're measuring your height. So, with that in mind, we'll take the distance between this and the intersection of this construction line and the top of that ramp, which is the dimension we're attempting to find. Find that distance, and it's 3.44 feet. And so, taking that plan and finding that same point of reference, which is just an extended line, this line extended to the edge of the ramp, we'll draw a vertical line, or I guess a line in the positive y direction that is 3.44 feet. And then because this is a ramp with a single slope, it's represented by that, we could just directly connect this point and this point, which occurs at 0 height. And then I'll delete that line. And the same sort of rings true for the rest of this. That's the process that we'll take for the rest of this plan oblique. We'll take the distance between that and the desired point, 3.48 feet, but I think because this is a landing, it is flat. So I'll just make it 3.44 feet so that it correlates with our other point, and that's the beginnings of our ramp. And you can use other kinds of symmetry, like we know that a ramp has the same slope at the front and at the back of that ramp. So we could just copy this line from here, from that point to that point, and that's the face of our ramp. We also know, well, I guess we don't know. Let's look at our photos to see if there's any change of height on this face of the ramp. I do not think that there is, because this is the dashed line of that other ramp. It comes up, and then I think this whole side back face is a landing. We'll see if we can verify that with photos. I don't have any of the proper photos of it, but I am quite positive that that is the condition there. And of course, a cursory Google search of the pavilion that you're drafting can help to answer with positivity those kinds of questions. But for now, assuming that this is flat, and being quite sure that it is, we can take this line of the plan, because that's the face it occurs in, and move that line up to 3.44 feet. And that becomes representative. Now this is beginning to become representative of our ramp. This is the back landing of our ramp. At this point, I think it's helpful, now that we're getting just enough lines, to switch our layer mode switch our layer so that we have a layer that all of our sort of keep lines, the lines we're keeping on the drawing, are going into. And that's how we're going to differentiate them from construction lines. So I'll change those layers. An additional thing that we'll get into, and maybe I'll do that with sub-layers, is we'll isolate parts of the oblique. So, for example, we'll have a layer for ramp, a layer for structure, another layer for stairs, let's say, and we can sort of divide up this project by its respective parts and use the oblique drawing to diagram those parts. So, these would be structure, this is our ramp, and then we can see our stairs here that occur on the inside. But I'm not going to totally draw all of those things, but I'll continue drawing our ramp and a little bit of structure for now, and then I'll sort of transition to the next step of the project. So now that we've got a bit of this ramp, let's trim away certain of these. You know, there's something occurring here that I'm not very... I'm getting sort of an odd line discrepancy, but let's try and fix this. Perhaps that is what's happening. Draw a line up there at 3.44 feet. And then a line back there. There's some difference between the widths of the ramp between the bottom and the top that was causing a difference in the line, in the angle that this line occurs in the plan oblique. So I think it's probably I was being a little bit lazy there when I attempted to just directly correlate them, and it caused problems. So if you're overly lazy in your attempts to find symmetry, you may end up with problems down the road. Anyway, another thing that I think is pretty helpful, at least for me, I always change the colors of my layers into these like extra bright, gaudy colors. That way I can sort of immediately see what layer things are on. It's just something that that helps me. So if I want I probably shouldn't do red for ramp because that's the color of my construction lines. Let's do orange for ramp. I'll move these lines to my ramp layer. And then this one is hidden behind the material of the ramp. And now if we were to switch off all our different other layers, our construction lines as well, you begin to see how that ramp is taking shape here. Trim away that line and move that. And this sort of angle change or face change there might be there, but it does sort of obscure the reading of the ramp right now. But yeah, so that's our ramp in plane oblique. And then just moving forward a little bit more from here, let's find maybe the corner of our building, project a line up. I'll turn on my construction lines again. Projecting a line up from that corner of my building that we want to find, and then finding the height between there and probably let's see, it looks like this back face comes up higher than that structure, that piece of structure here. So if we want to find the front corner, which is just the structure, we will find it on this elevation and find this height here, which is there, so that's 12.5 feet to the top. So we'll draw a line now in the positive Y direction and on our structure layer, positive Y up 12.5 feet. And now we'll repeat that same process for this corner. There, and I believe it looks like it comes across to the same point, so we could just copy this line across. Like so. And keeping on the structure, we'll move it there. And because now we have our top height, we could take lines from our plan, like the bottom pieces of our structure, and we could project those up. And then trim away our tags, and our structure's sort of beginning to take shape. And now looking at the drawing, it does look like there's a difference between the structural members and the widths of the structural members and their heights, because they're two adjoined frames. This is a better view of it. Yeah, so I guess it's 2 times as wide as it is tall. But perhaps we'll just go into, just have to find the proper drawing, I think. Which is why it's helpful to have as many drawings as we have. But 0.17 feet for that, the structural height. And at let's take this intersection, for example. At this intersection, this structural line, the bottom of it occurs 3 feet up, and it's 0.17 feet tall. So, from the outside of this member, we go up 3 feet, and then up again 1.7 feet, or 0.17 feet for our height. And because these things are horizontal and carry across the facade, we could just copy them from one point to another and then connect those respective points. And now we can extend those lines. So hiding the ramp and isolating for structure, we end up getting a frame that looks like this. And then you just project lines up so that every corner of the plane is represented. And then we'll copy that line. And like so, our structure begins to take shape. Okay, so now that you've sort of bared with me as I'm going through all the different pieces of the drawing and isolating, I'm going to switch gears and I'll show you the drawing that Erica made earlier. That is over here. And this is sort of where she got to with the drawing. So her ramp, you can see with the railings, and then all those different structural components across, and the stairs going down. This is pretty close to finished on a plain oblique drawing. Now there are a couple extra lines, so hiding the plan and these reference lines she gave for herself and turning off construction lines. Now this is much closer to where the final would be. So the last thing I'm going to show you guys how to do is I'm going to show you guys how to hatch for the purposes of highlighting a surface. And we'll just do that very simply with the section of the ramp that we constructed. And the way that you're going to do that is you'll highlight your lines and you'll type in hatch. And then you'll select your chosen surface. I'm going to select the surface that people circulate on. And then you'll press enter. And from here you can go through different hatch patterns. The important ones that I'm going to cover are the solid, which all you have to do for the solid is just press enter and it appears like that. And the color can be determined in the layer. It will display as the color of whatever layer it's in, but it can print to a different color. So that's one thing. The other hatch I'm going to cover is 45-degree lines. And so selecting in the region that you want to hatch, after selecting close regions of lines, you can select your desired hatch. I like this one. I like the spacing of it. It's just evenly spaced singular lines. And you can specify a given rotation, so that is a 45-degree rotation there. And I pressed enter too quickly. That's a 45-degree rotation. And then you can modify your scale. So a larger scale will result in a larger spacing of lines, and a smaller scale will give you a tighter spacing of lines. And that's just something to play around with. So that is, I'm going to settle on that spacing. And that's one, hatching is a strategy for highlighting different surfaces and calling them out as meaningful. The last thing I'm going to show you guys how to do really quickly is to plot your drawing. So once your drawing's done, and I'm going to move over to this drawing that is just about finished. Once your drawing's done, we're going to need to plot them in a relative scale because we've drawn them such that their dimensions are the same as the dimensions of the pavilion in real life. So we need to plot them get it to fit on 11 by 17 drawing. And so we'll highlight our lines and type in print. And once we're here, we'll select our 11 by 17. And I think perhaps for the proportion of drawing, a portrait would be best. And then what we're going to do is we're going to go down, once you make sure all your other settings are appropriate, we'll go down and we'll select our desired scale in this menu. So we'll go down, and first I'm going to try a 1/4 inch equals a foot scale. And now that that is set up, it will set my window such that my 11 by 17 is scaled at a 1/4 inch. And that's a little bit too large of a scale for my drawing to fit perfectly on a single 11 by 17. And so we'll go back to this and we'll change our scale to 1/8 of an inch equals a foot. And now we'll reset our window, and I'm okay with those margins. And let's go to black and white. The important thing is that once you set your window, you don't click and drag, because that resizes your window and your object. So that rescales the whole thing. And it'll give you sort of this warning bubble, change scale to fit window area. We don't want to change the scale, so we'll click no. This is an 11 by 17 scaled in your document to 1/8 of an inch equals a foot. So that's what we need to print to. The last thing that I'll go through just real quickly after printing is line types. How we'll get to our line types and controlling them. For example, if I wanted this line to be dashed, I could set it here to dashed, which if I turn on my print display, I believe it will show up. No, I guess it will not. But if I printed it, it would have, this line, or I guess that's why that is happening. I did not change the appropriate line. So if I change this one, the final thing, to dashed, perhaps, and then I turn print display on, maybe not. It will not. Anyway, if I print it, you will see that all these lines end up being dashed. And if we want to change the scale or the pattern of that dashed line, we'll go to File, Properties, and then we will go to Line Types here. And you can select your different line types. I actually generally prefer to add a line type. And then we can change the pattern of that. So 1, 2, 4.25. And you can see that that has implications for the display of that line type here. If I do 1, 2, now it's a dash of 1 unit, of 1 millimeter, and I can change that to inches as well, and a dash of 1 millimeter, and or a dot of 1 millimeter and a dash of 2 millimeters. Anyway, that's something to think about, and we can change our line type scale as well. So if you're plotting if your drawing is really, really small, or your object's really, really small, then perhaps, if your object itself is 1 millimeter across, then this pattern would be way too big. So we'd have to scale down our line type scale a lot in order for that dash to register when we print it. Sorry for the long tutorial, everyone. Lots to cover, but I hope that you all enjoy your day, and thanks for bearing with me.